Example 11. We want to solve a differential equation d2y dx squared minus 2 dy dx equal to 4. Given initial condition when x equal to 0, y equal to minus 1, when x equal to 0, dy dx equal to 2. So first step is to take Laplace transform of each term. So we get Laplace transform of d2y dx squared minus 2 dy dx equal to Laplace transform of 4. Now, step 2. Find the Laplace transform of each term. Where can you find them? It's in the formula card here. First, we find the Laplace transform of d2y dx squared, which is in this formula. Laplace transform of d2y dx squared is s squared Laplace transform of y minus s times y0, y at 0 at minus y prime at 0. So write down the first term. First term is actually s squared Laplace transform of y. Do you know what is y? We don't know. We're going to find out what is y here. Or our main object is to find out what is y here. Minus s y of 0 minus y prime of 0. So this is the first term using the Laplace transform. So let me use the bracket here. So this is actually the first term. Alright, so taking Laplace transform of first term, d2y dx squared, and minus 2 Laplace transform of dy dx. Okay, it's actually using this formula now. Here, this is equal to bracket here s Laplace transform of y. We don't know what is y. We're going to find out what is y here. Minus y0. Okay, so this is for the second term on the left hand side. Then Laplace transform of 4. Now, where is Laplace transform of 1? Laplace transform of 1 is 1 over s. Right? Just remember, Laplace transform of 1 is 1 over s. So Laplace transform of 4 is 4 over s now. Okay, so this is actually from the right hand side. So now you put in, substitute the value now, this step 2. So now we do step 3 now, substitute the value. Step 3, substitute what is y0 and y prime 0. We know y0 is minus 1. Y prime 0 is 2. Then y0 is minus 1. So eventually you get s squared Laplace transform of y minus plus s here now, minus s times minus y is plus s now, then minus 2. Then this side here I have 2 s Laplace transform of y minus 1 becomes plus 1 now, equal to 4 over s. Okay, so this is step 2 and step 3. Substitute initial condition. Step 4 is rearrange the equation now to make Laplace transform of y the subject. So let's collect all the Laplace transform of y together first. Let me expand out for equation first. Okay, s squared Laplace transform of y plus s minus 2 minus 2s Laplace transform of y minus 2 is equal to 4 over s here. Now collect all the Laplace transform of y together. So these are the Laplace transform of y you have. So we get one term here, s squared Laplace transform of y, and minus 2s Laplace transform of y. So these are the two terms Laplace transform of y together. Yeah, s squared minus 2s Laplace transform of y. When I collect them, then the rest is 4 over s. Shift the rest to here, you get minus s here to the right hand side, and minus 2 become plus 2 to the right hand side. So become plus 4 now. So what is Laplace transform of y now? Is equal to 4 over s minus s plus 4 over s square minus 2s, which is actually 4 minus s square plus 4s over s square minus 2s after divide, making common denominator, and this is actually 4 plus 4s minus s square, then pull out the s again, get s square s minus 2. So they're making ly the subject on the left hand side. Step 5, you do partial fractions on the right hand side. So 4 plus 4s minus s square over s square s minus 2, because the s square term is repeating factor. So it's going to be a over s plus b over s square for repeating factor, and then c over s minus 2. Now you can use the cover to find a. You can find cover. You can use cover to find b and c. And then a, you have to use the compare coefficient. Okay, this is a general rule for cover up and compare coefficient, or we can use compare coefficient straight away to find out a, b, c. But let's do a cover up to find b and c first. To find c, what you do is c is equal to, okay, c is equal to cover up 4 plus 4s minus s square, where you cover up s minus 2, s minus 2 cover up to c, and then put s equal to 2. So you get 4 plus 4 times 2 is 8 now, then minus 2 square is 4 over 2 square is 4 here. So happen you get 8 over 4, which is 2. So I know c is equal to 2 now. So c is equal to 2, and c is equal to here. So you can know c equal to here. I can also find b. B is a term above of s square. So I cover up s square now. S square cover up. You left with only s minus 2. And you put s equal to 0. So you get 4 plus 0 minus 0 and 0 minus 2. And then you have minus 2. So b is equal to minus 2 now. Okay. And what is left is the value of a above s. Okay, to find the value of a, you multiply the expression on top here. Okay, multiply by s squared times s minus 2. Then you get 4 plus 4s minus s squared is equal to as s minus 2 plus b s minus 2 plus c s squared. Okay, now we can compare, define a, right? Compare. Let's say s squared. The left hand side is minus 1 s squared. The right hand side, the s squared comes from as times s squared, and then c times s squared. So a plus c, as squared plus cs squared. Because the middle term no s squared anymore. By comparing s squared, I know what is a now. So a is equal to 1 minus 1 minus c. But what is c? We have found out earlier. C is equal to 2. So it's minus 1 minus 2. So minus 3. Okay. So let me see whether I made a mistake here. So a is equal to a minus 1 is equal to a plus c here. So a equal to minus 1 minus c, and c is equal to 2 here. So this is minus 3. Okay. So therefore, what we have is actually Laplace transform of y is equal to minus 3 over s plus b above is minus 2 s squared, okay, plus c is minus 2 again, s minus 2. Right? So what is y now? Y is inverse Laplace transform of minus 3 over 1 over s plus minus 2 inverse Laplace transform of 1 over s squared plus 2 inverse Laplace transform of 1 over s minus 2. Now, all this can check for formula now. Laplace transform of 1 we know is 1 over s. Laplace transform of t we know is 1 over s squared. And Laplace transform of e power 2t is actually 1 over s minus 2. This we know from standard Laplace transform table. So therefore, this answer minus 3 times 1 minus 2 t, and then plus 2 e power 2t. That is how we get the final answer of example 11.